Alright, ladies and gentlemen, this is going to be our next video on water and polarity. So let's get started on this next video. So what is the significance of water? Well, if we think about it and we were to break the Earth down into a pie chart, we would see that 71% of the Earth is covered in water. And water is really significant because all organisms depend upon it in their ecosystems and for sustenance and survival. So if we think about humans here, well, without water, we would no longer be able to maintain homeostasis and we would die. 60 to 70% of your body is actual water molecules. And water is important for a variety of reasons. It helps carry nutrients and oxygens to cells. It moistens oxygen for our breath. It makes up 83% of your blood. It helps convert food into energy, makes up 75% of your muscles, lubricates your joints, accounts for 22% of the bones in your body. Your brain is 75% water. For all of these reasons, water is extremely significant and important for our survival. Now, recently, we've gone through and sent drones to Mars, and we've been able to find significant parts of the planet have water potentially in a liquid state, but also in ice. So Mars and the exploration of Mars is going to be growing as we see its importance to humans because of its ability to contain water both in a liquid and a solid state. So let's think about the water molecule here. So remember, a molecule is a group of atoms bonded together representing the smallest fundamental unit of a chemical compound that can take part in a chemical reaction. So water is going to consist of an oxygen atom and two hydrogen atoms, and they're going to be combined together. So if we were to model what a water molecule would look like, it would look something like this. And this is about approximately to scale. The oxygen atom is much larger than the two hydrogen atoms. Remember, because oxygen has 8 protons, and in this case, hydrogen only has 1. So the nucleus of oxygen is larger, and the nuclei and orbitals and shells around the hydrogen atoms are much smaller. So remember, this is somewhat proportional for this model. So what is a polar molecule? We've been talking about this for a while, but I haven't really gone through and explained it in complete detail. So remember, we have a water molecule, we have oxygen, 2 hydrogens, and remember the electrons are being shared, and that's what the arrows here represent. Now, a polar molecule, I'll give you the definition first, is a molecule that has a slightly positive side and a slightly negative end. That's what we call a polar molecule. Let's try to understand what that is. So remember, when we have covalent bonding, we're sharing electrons. So when we're talking about hydrogen bonding, it's a result of uneven sharing of electrons that create a charge. So let's go through and look at a water molecule here and look at one electron that's going through, and we'll just say it's orbiting around this particular molecule. Now, this electron, watch it, it's going to spend more time around the oxygen because the oxygen is a larger atom. So the reason that we have a negative charge up at the top of the water molecule is because, well, the oxygen atom has more mass. Because of that, the electrons are going to have more of a tendency to be around that oxygen. Now the hydrogens, they're not going to have as much mass. They're going to be much smaller, so the electrons are going to spend less time around them. This is what creates the partial negative charge, which is represented here in the yellow, and the partial positive charge on the hydrogens represented here in the purple. Now remember, this is not like covalent bonding where it's a complete negative or complete positive charge. It's a partial charge, so it's partially negative. It's not totally negative because the electrons can be around the hydrogens as well, but it's, we can say, mostly negative most of the time because of the size of that atom. So when we look at polar interactions among molecules, well, what we get are these patterns. So right here I have 3 water molecules, and remember, they have a negative charge at the top of the oxygen. Let's just say at the bottom where the hydrogens are, that's a positive charge. If we continue to add water molecules, well, they're going to go through, and remember, opposite charges attract. This is what we're talking about when we talk about hydrogen bonding, and this is what creates the structures and interactions amongst the water. So we can see the positive and the negative, they're going to want to be attracted. Now remember, they're not as strong as ionic bonds because remember, it's only partially negative and partially positive. So the bonds can be broken and remade easily, unlike ionic bonding. So if we continue to add the water molecules, what we can see is the interactions that we get amongst these molecules because of the partial negative and partial positive charges. So remember, this is a bond between charges, not the sharing of the electrons. So remember, we're creating bonds between different molecules here, based on the charges, the partial charges that they have, and we're not going through and sharing electrons amongst the water molecules here. So let's go through and look at the structure in a little more depth. So let's go through and try to remember. Covalent bonding is the bonding between the hydrogen and the oxygen. Remember, the hydrogen's in the red, the oxygen's in the blue. And those bonds are created by sharing the electrons between the oxygen and the hydrogen atoms. Polar bonding, or the hydrogen bonding that we're talking about, is because of the partial charges that exist amongst the water molecules. The partial charges are creating what we call hydrogen bonds. So the distinction that you guys have to make when we're talking about hydrogen bonding here is covalent bonding is between the hydrogen atoms and the oxygen atom, whereas hydrogen bonding is between two water molecules. I'm emphasizing the molecules. So hydrogen bonding, this is the attraction between a hydrogen atom and one or more water molecules where the hydrogen comes in contact or bonds, creates a partial bond with the oxygen atom. Two molecules of water, that's what we're getting with hydrogen bonding here. And again, we can see the interactions here in this animation, and you can see how they interact based on the partial positive and partial negative charges of the molecule. So just so we are absolutely 100% clear on the difference between covalent and hydrogen bonding in water, I'm going to go through and look at this animation here with you. Now, covalent bonding, this is the bond between the oxygen and the hydrogen atoms. Whereas the hydrogen bonds, this is the interaction between the water molecules because of the partial charges. So if you get confused, go back to this image that you see in your note packet and you can see the difference between the two. One is between two water molecules, that's the hydrogen bond, and the other one is between covalent bonds between the oxygen atom and the two hydrogen atoms. Molecules versus atoms, that's the difference here. So as we go through and talk about hydrogen bonding, we can get into more specificity for how the water bonds with different substances. So there are names for how the water bonds. We have cohesion and adhesion. Now cohesion is going to be when water and water, so two polar water molecules go through and hydrogen bond to each other. And this is going to go through and have a couple different effects. Adhesion is when water and another polar substance goes through and they bond together. Now, if we look at this in a little more detail, cohesion is going to have an effect on the surface tension, or how the surface of the water is different than the body of the water. And that's important for us to understand a couple of different organisms and ecosystems. Adhesion is really going to be important for capillary action in trees, and water moves up and through substances because of adhesion and capillary action. Now, if we go in a little more detail here, solution and suspensions depend upon cohesive and adhesive forces all mixing together and playing in one body. So let's go through and look at cohesive forces, or cohesion. So cohesion is when one water molecule sticks to another water molecule due to hydrogen bonding. And cohesion is going to create what we call surface tension. Now, surface tension is a measure of the strength of the surface of a liquid. So what we have are the interactions, the polar interactions amongst all the water molecules here. So we're going to pretend the gray circles here are our water molecules, and then the black arrows represent, in this case, all of the polar interactions that we see. Now, a water strider, the reason that they can walk on the surface of the water is because of the cohesive forces and the surface tension that the water creates. There is slightly more tension, or there are slightly more forces along those first couple layers of molecules, which create something similar to a solid surface, dependent upon, one, the forces that are on the bottom of the feet of the insects, and then also the gravitational force that is being applied to that insect, which is usually dependent upon the weight. So surface tension is dependent upon the polar interactions amongst these molecules, and we can see surface tension exists at the top layer of the water body. So this is going to produce a film that allows small insects or other organisms. Sometimes there are also reptiles such as lizards and geckos that can go through and somewhat scatter across the water. But the surface tension of a liquid results in the imbalance of intermolecular attractive forces, so the cohesive forces, the polar interactions amongst these water molecules. And because the water molecules are in contact with air and water, what we get is an imbalance in the intermolecular forces, which creates stronger forces towards the surface. So a molecule in the bulk liquid experiences cohesive forces with all other molecules in all the directions, whereas the molecules on the surface only experience it from the sides and the bottom. The rest of the interactions that occur amongst those water molecules is coming from the air, which is what is going to go through and create the surface tension. So a molecule at the surface of a liquid only experiences a net inward cohesive force. So let's go through and talk about adhesive forces here, or adhesion. Adhesion is when a molecule forms a hydrogen bond to another substance, so not another water molecule. So let's say we have two water molecules, they bond together. That is what we call cohesion. But if we have two polar molecules here, when they go through and interact and bond to each other, this is what we call adhesion. So you have cohesive forces between two water molecules. Adhesion is between a water molecule and something else. Now this is going to lead to what we call capillary action. So capillary action is an example of adhesive forces, and this is what causes water to move from the roots of a plant or a tree up to the leaves, the stems, and the flowers in the tallest part of the tree. And without capillary action, trees would not be able to go through and move water to all of the necessary places where they need water. So if we look at capillary action in a little more depth here, we can kind of observe it through this animation. So let's say I go through and put a straw in water. What we're going to see is the straw is going to uptake some of that water because there are some polar interactions amongst the plastics within that straw. Now, this is kind of analogous to the tissue as it's moving water through the different tissue systems of the plant. There's a negative charge on the cell walls of the plant cells, and the water, again, remember there's partial negative and also partial positive charges, and this is going to cause the water to move through the tissues of the plant. So plants really depend upon this because without it, again, they're not going to be able to move water to the leaves, hydrate themselves, and allow photosynthesis to occur, which is enabling them to make sugars and food. So let's go through and look at the differences between cohesive forces and adhesive forces. So when liquid water is confined in a tube, its surface, or meniscus, has a concave shape. And if you go through and look at a chemistry class, you will understand what the meniscus is, and we will also be going through and looking at this in class. So we want to think about which force is stronger here, cohesion or adhesion. Well, if we look at the meniscus here, we're going to have our water molecules. And in this case, the water molecules are going to be interacting with each other. Now we also have adhesive forces at play between the sides of this wall here for this tube and the polar water molecules. So we have the cohesive forces between the water molecules, adhesive forces between the walls of the tube that we're looking at here. Now, which force is stronger? Well, remember, the meniscus is being curved upward. So if we were to look at this, it would appear that adhesive forces are pulling more, or the forces between the water molecules and whatever polar substances on the sides of the wall are greater than the cohesive forces. This is what's causing the curve in the meniscus that you will see if you put water in a test tube or you put water in a graduated cylinder. So if we look at this, it depends on what substance we go through and put in test tubes. So on the right, we have water and the meniscus curves down, but we can see we have liquid mercury on the left, and liquid mercury, the cohesive forces between the mercury atoms and molecules here are greater than the adhesive forces between the glass and the mercury, so therefore the meniscus is going to curve down. So it really depends on the substance, but if we're looking at water, well, the adhesive forces between the glass and in this case the water molecules is greater than the cohesive forces between the actual water molecules themselves. So did you learn? Well, did you learn a couple of things? Did you learn why water is important? Did you learn adhesion versus cohesion? And did you guys go through and learn the difference between surface tension, capillary action, and why they're important to life on Earth? This is going to be the end of the video. I will see you guys in class tomorrow.